Login accepted.
I think. Okay. Hi. Hello, everyone. My talk's going to be covering lateral movement, specifically how adversaries laterally move across Windows networks. This talk, I got the idea for this talk because normally this is a pretty common tradecraft when it comes to my line of work. Or if you are if you do CTFs and you do say hack the box, work a lot with Windows. But after I was talking to some people who were also working in security, I realized that while the term lateral movement is like pretty often mentioned, the actual specifics of how it works isn't so, that information doesn't seem to be known as much. But I thought at the very least, this could be a neat piece of information, poke fun at Windows. And for people working in security, this might be helpful to provide some context when people say there's lateral movement or within the context of a Windows network, you might understand how they actually went from point A to point B. So some background information about who I am before we continue. My name is Dylan Tran. I'm a part of the adversary simulation team at Express Red. Currently an intern, and I will be returning full-time in a few months. I have some contact information and also part of the CPTC and the CCDC teams for Cal Poly between 2021 and 2024. And I'll also be graduating this semester. I was also the director of Academy for Swift last year. Primarily for work, I do a lot of Windows internals and malware development. And I also do that for my own pastime, fun. And if those letters on the bottom indicate anything, it's that I have very poor spending choices. So before we move into lateral movement, I wanted to give a definition of it. And so according to MITRE, the adversary is trying to move through your environment. Lateral movement consists of techniques that adversaries use to enter and control remote systems on the network. With that, I mean, I think that's pretty self-explanatory. Adversaries are going from one point to another point and obtaining control within your network. Specifically for the context of this talk, I will be, the systems in question are going to be Windows workstations, Windows servers, any sort of Windows endpoint. Because technically lateral movement can be more than just moving from computer to computer, be moving from computer to a specific platform, a specific application or technology. But for this talk and all the techniques that will be covered, it's just talking about moving from Windows computer to another Windows computer. So a question for the audience before we move forward. Why do you think adversaries try to laterally move? Anyone wants to try to answer that? Yeah, this may be true. The adversaries might want to do ransomware. That's pretty often is the case. In general, adversaries want to laterally move because it accomplishes some goal in their campaign, whether it is part of the goal is, okay, they want to obtain administrative access to the whole network, and laterally moving to a host helps achieve that, and they might do that. Or in the case of ransomware, someone deploying ransomware might want to have as much coverage over the network as possible so the ransomware has the most impact and gives them the most leverage in negotiations. I've classified the different ways to laterally move on Windows into three sort of classifications. It's a little arbitrary, but we have administration tools, which are what people and sysadmins use to sort of administer and configure a system, which can be used maliciously just as it can be used to configure the system. Exploits, which are an abuse of some sort of software flaw within a piece of technology, and Windows features, which are similar to administration tools, but they aren't necessarily there to administer the system, but there's weird quirks of Windows that you can use in funny ways. More on all of this as we continue through the slides. So first, exploits, and I'm going to keep this brief because exploits are a very complex topic within themselves. Exploits, as I've said before, they sort of leverage a programmatic flaw in the software leading to unintended behavior. For exploits in particular, usually it is sort of controlled. When you run an exploit, generally there is some sort of deterministic behavior that's advantageous for an attacker using the exploit. Not all exploits lead to lateral movement, which is why I pointed out these two exploits, in particular MS 67 and 17010, the latter being also known as Eternal Blue. Exploits can lead to different things, and in this case, these two exploits led to unauthenticated remote code execution, and which meant this was pretty much initial access for an attacker, but also it could be weaponized for the case of lateral movement too. TLDR of how these things worked is the vulnerable piece of technology was a service running on Windows called SMB, which ran on PC 4445. And by sending a specific weird set of input over the network, you could elicit some sort of controllable behavior, some sort of controllable action from those servers, in this case, executing code. That code would often be a piece of malware. And because the program, the software that was vulnerable to this SMB, ran on Windows as system, which you could think of it as an account context slightly or similar in privilege to administrator. This led to unauthenticated code execution as a very privileged context. The bulk of this presentation is going to focus on using administration technologies and Windows features. I noted that it's not a bug, it's a feature, because a lot of these things, after I explain them, you might be thinking to yourself, wow, this is seriously a thing. And yes, a lot of these techniques have existed for a long time because they are features, they're not bugs, so they don't get fixed and they get routinely abused. A little bit of background information before we go into more depth about the different techniques though. Windows is typically integrated into an Active Directory context, and this is very important because lateral movement requires both, typically it requires a form of authentication and authorization, a level of access. If you were at the internal net testing talk a little earlier, that would help a lot for some of this context. But basically, within an Active Directory network, there's a concept called domains, which you could think of as sort of boundary that is managed by a domain controller. And when you are in that domain, such as within a domain user context, you can authenticate into any domain joined machine. For example, in Cal Poly, you can use your Cal Poly account to log into the computers in the library. So that covers the authentication part. When it comes to authorization, lateral movement typically requires administrative privileges. That previous talk talked a bunch of different ways that you can get credentials and escalate privileges within Windows. TLDR, it's not very uncommon to have high-level access in Windows, maybe not necessarily over the whole network, but over one or two or multiple different assets for various reasons, such as different techniques that you can use on Windows, or the fact that the permission model in Windows is pretty weak, and oftentimes accounts are often overly permissive. And the last thing to note is that service I mentioned earlier, SMB, it can provide file system access if you have administrative access to the computer that you're trying to access SMB on. This is important because you can be able to remotely upload and download files, but the upload part is more interesting for us as attackers because it chains really well into the rest of these techniques that I'll be talking about. So first, RDP, there's not a whole lot to say about this one. It stands for Remote Desktop Protocol. And if you are authorized to, so you're in the Remote Desktop Users Group, or however the network is configured, administrators are administrators are allowed to RDP by default. You can log into a computer remotely. And for example, the RDP client I'm using is called XVRDP, and I specify administrator credentials to a specific computer called King's Landing, and I log in. There's really not much to say about this. If you can log into something, you can download and run software on it to establish command and control or some other form of persistence. This is just using administration technology in a way that, well, probably shouldn't, but since we're in the context of trying to simulate an adversary, this works out for us. Then there's WinRM, or Windows Remote Management, which is similar to RDP, but rather than giving you a UI access, it is a protocol that operates over SOAP, which is a sort of like HTTP web API type of thing. Rather than being a remote desktop users, you need to be within the remote management users group. Once again, though, anybody that's a part of local administrators on the machine or has any form of administrative access can typically WinRM in. Most of the tools that you can use to perform actions over WinRM are typically going to be CLI based. PowerShell offers a native capability to do so via the enter PS session commandlet. Now, next thing, the next technology you have is something called WMI. According to Microsoft documentation, you can write WMI scripts or applications to automate administrative tasks on remote computers. WMI also supplies management data to other parts of the operating system and products. The interesting part is bolded, is that you can automate administrative tasks on remote computers. That sounds like a whole lot like I can do things on different systems. In other words, I can run commands, or maybe I can install and run different software on a remote system, which is exactly what we can do. WMI itself is a pretty complex piece of technology, and the way it works is it could be a long discussion of its own. But for our use case, what we can do is we can request a class over the network from WMI. There's a bunch of different classes that WMI exposes, one of them being called Win32 process. It's sort of like in object-oriented programming, these classes, or I guess these objects, have functions that you can call. So in this case, the Win32 process class has a function called create. So we can just create a process. And if we chain that with what we know about SMB, we can upload a file, say a command and control implant, and now we can use WMI's Win32 process to execute it. And if we don't want to do that, we could just use WMI and Win32 process to run arbitrary commands that we would on a normally do in like a terminal, like PowerShell or command prompt. There are different techniques and toolkits. I was too lazy to find any more than the super basic stuff. You have WMIC, which is the built-in Windows executable. That's the command line interface for WMI and speaks WMI, because most of this stuff you have to do programmatically. And then there's a part of the in-packet suite, there's something called WMI exec, which uses WMI to run Win32 process and run commands in the output. There's other ways to abuse WMI, but it's a lot less straightforward. So I've linked the blog there below if you want to read it, but it's a bit more heavy on the technical side. Using WMI, specifically WMIC, the command line on Windows, this is one way that you can run a command. In this case, the command I'm running is just notepad.exe. I'm just running Notepad on my own systems, which I specified by the node localhost. At the very top, I also use WMI just to get arbitrary operating system metadata, but that doesn't really matter here. It's more so the fact that we can specify a host to execute a command on. The actual flow of this whole process is pretty simple. As I lay down this diagram, you have your attacker machine, which gains access to this Win32 process class from the WMI server that is running on the Windows target, which it does by default. And then that's going to return to the attacker a handle to Win32 process, which we can use called create. And that create is just going to start a process of our choosing, whether it is an executable we've uploaded, or if it is, let's say like command cmd.exe/c who am I, or whatever. We also, to check for administrative privileges, made a little typo here, but I also like to, personally, I use SMB client just to see if I can access to the $C share. if you have access to a $C share, you typically have some form of administrative access to SMB, which usually extends. Means if you have admin to SMB, you probably have admin for everything else due to the way the Windows services and authentication works. And as for the running commands over WMI through InPacket, I've just basically translated the syntax over with the administrative credentials into the arguments that the InPacket scripts takes, and I just say, hey, WMI exec, make connect to this system with these credentials, and it gives me this sort of shell-like interface. It's not actually a shell. That's just visually, that's what it looks like. I just specify commands I want to run, and then the script is going to tell WMI to spawn command prompt and run the commands that I'm specifying. Then it's going to write it to a file and read it out back to me. And that's how I get my output down at the bottom over there. Next up, we have services. So services are really just these background processes that run and exist on your computer. If you open up, if you go to your little search bar on Windows and you type in services, it should, you should be able to get this sort of MC document that has all this service information. So screenshot I have is exactly what that is. And if we click on one of those services to actually take a look at what service configuration sort of looks like, there's multiple tabs and boxes, but we just take a look. We have a name, a display name, some start information, whether it's running or not. And right in the middle over there, we have the path to an executable, because services are really just a wrapper over running programs just so they can run in the background computer. These services are controlled by the Service Control Manager. According to the Microsoft documentation, Service Control Manager, SCM, is started at boot. It is an RPC server, so that service configuration and service control programs can manipulate services on remote machines. Keyword there, remote machines again. So we have a Windows feature that runs a program, and by design, the way this Windows features work that is it's callable remotely. This is another primitive for us to get our executables running on a remote system. So just like we did in WMI, we can't just upload a file via SMB, and then rather than using WMI, we can use Windows service feature to run the program remotely to whatever computer service control manager we're authenticating into. If we don't want to run a program that we upload, we could just tell the service control manager, hey, the service is going to run cmd.exe/c or PowerShell tech C to run a specific interpreter syntax that it accepts. Now, there's a lot of techniques and toolkits that have been created to abuse this service feature, and some of them aren't really intended to abuse it. They just use it normally, such as sc.exe, which is the built-in Windows executable that is used to actually interface with the Service Control Manager. But using sc.exe, you can actually remotely communicate. You can communicate to a remote Service Control Manager and install services on system and make them point to files that you copied over to that system. Then there's a binary as a part of the Microsoft Sys internal suite of tools called PSXEC, which installs a service on a remote computer to let you sort of basically have a shell on that remote computer. This isn't malware, though. This was a legitimate executable. I believe the use case was for some remote administration purposes, but just as we covered earlier, anything that's used for remote administration can probably and equally be used for malicious purposes. Then there's two different sort of InPacket scripts that leverage this tradecraft, and there's another thing called SC shell, where rather than creating a remote service, it modifies an existing service to run a different executable or reverting it. But they're all basically the same thing, really. There's an example of services being leveraged for lateral movement in this write-up from the DFIR report. All of these techniques that we'll be covering have been abused by either red teams or actual adversaries out in the wild before. I was just a little too lazy to find a lot of examples of it. So I will hope everybody takes my word for it. The way PSXX, which is one variant of the tradecraft of service abuse that a lot of people refer to, the way that tradecraft actually works is from the attacker machine, you create a service on the target computer, and then after you create the service, you upload payload. Technically, these could be done in any order. The service could point to an executable that doesn't exist. It doesn't matter until the service tries to get started. Afterwards, the attacker is going to tell the service control manager to start the service that they created, which is pointing to the malicious executable, and the service control manager is going to run the executable. And wow, now the malware is deployed, the command and control is established, and from there, an attacker could do all the typical post-exploitation they would do. PSXX, at least the in-packet script, is pretty often blocked by any form of antivirus, though. That's because it's uploading a really well-known malicious binary in the process of trying to achieve what it does. So yeah, it creates a service with a random 4-letter name, and then it uploads the malicious executable into C Windows with another random file name. So instead, we can look towards something called SMBXX, which is not like 99% similar. It creates a service and then starts it. Rather than uploading an executable, it just tells the service to run a command prompt command with and to output the file to output the output into a certain file where the tool will then read to give output to the attacker. So basically, same process: create service, start it, and that process starts. In this case, it's a command prompt command with whatever command of your own choosing. In this case, using a wrapper around in-packet called netexec, I just specify to run the whoami command. It's going to create a service. That service is going to run cmd.exe/c whoami and then write it to a file. Then netexec is going to read that file. In this case, it tells me that I'm running a system. By default, with the configuration or the way the tool is created, the services are run as the system account rather than the identity of the user that created that service. And for the last thing that I wanted to cover for today's talk, I have no idea how we're doing time, by the way. Hope we're doing good. We have schedule tasks. You can open up your task scheduler on your own Windows system by just pressing the home button, search bar, just like we did with services, and they do certain things at certain times and triggers. If you try to create your own task, you can see fairly simple. You have task name, description, what triggers it, and an action. In this case, it's starting a program in C Windows with a flag that is a URL. Doesn't need to be a URL. I just chose to do it. Schedule task, run through the task schedule services. Task schedule service. And according to the Microsoft docs, task schedule service allows you to perform automated tasks on a chosen computer. With this service, you can schedule any program to run at a convenient time for you or when a specific event occurs. So once again, following that common trend of, wow, Windows has a feature that lets me run things on a remote computer as a feature. Okay, let's use this to deploy funny stuff. So following the exact same formula we did with everything else, you can upload a file via SMB, or you could just create a task to run a command prompt command, which is rinse and repeat. All these are just really a different way to execute a file on a remote computer. We have different techniques and toolkits which abuse this. I was too lazy to find anymore, but you have schedule tasks.exe, which is built-in Windows executable to interface with the task scheduler, or you could use the GUI as I was showing you before. Or there's another in-packet script that sort of implements this abuse through Python called in-packet ATXX. The way this works is very similar to all the other diagrams I've already showed you. You have an attacker machine. Rather than creating a service or rather than prompting WMI, it just creates a schedule task and then starts it. If you want, you can upload an executable in the middle if you want that particular executable to be run. But these are all like super similar ways really of just running commands or running executables. Which is why Windows lateral movement is so much more prevalent than if you were to compare it to lateral movement on other operating systems such as Linux or Mac. You probably don't hear it a lot, or all it really is wow, they use an like an authentication port such as SSH. But you don't hear anything else about that, about like ransomware being deployed all the Linux systems, because that's just there isn't as much built-in native support for this type of lateral movement, whereas Windows just has all these features that are free to be abused. Anyways, in packet ATXX, similar syntax, similar to everything else. You just run ATXX, specify some admin creds, specify a command, and it just runs the command. Similar to the other in-packet scripts, it will create a task, then it will delete it. That task will run your command and write the output to a file that it'll read and return to you. In this case, scheduled tasks have the option of either running as system in the configuration or of the identity of whoever created the task. But in this case, it just runs as system because that's just how in-packet works. That being said, are there any questions? I think this was a little quicker than I anticipated, and I left my phone somewhere, not with me, so I don't know what time it is. Oh, awesome. Yeah, plenty of time for questions. Awesome. Oh, never mind. Generally, we, at least from what I've seen, we don't use impact as much. There's different ways to achieve lateral movement. We use a lot of in-memory post-exploitation tradecraft that does the job, but it's all really doing the same thing where we're using a tool that abuses those technologies I stated, or some other ones that I haven't gotten to yet, and we use them to execute a file or execute a program that we've messed around with. Awesome. Oh, fine. Right. So there are, depending on the different technologies that is being used for lateral movement, there's going to be different sources of telemetry. For example, when it comes to services, there's service creation logs. There's logs for when a service gets started. There's logs for when a service is modified and turned off. So for detecting service-based events, you can look for something anomalous based off of those. As for WMI and scheduled tasks, I'm not sure if there's the exact same telemetry exposed, but I believe there is something along the lines of that is exposed. Another thing that defenders can look into if they have the infrastructure set up is to use some sort of network logging, for example. All the technology, at least all those Windows features I covered, services, WMI, and scheduled tasks, those all work through communicating through RPC on Windows and then targeting some ephemeral port where the server is actually listening on. And if you have some sort of network access controls on that, blocking Windows computers that don't necessarily need to communicate with each other, or at least logging when that type of event occurs, that could probably be useful in detecting some sort of weird activity moving from one host to another. Since all of these are built-in features available by default, they're pretty often abused in the case where someone is laterally moving. Oftentimes, attackers will take like the easiest routes. Like, well, if the remote desktop is open, they'll just remote desktop in, right? Okay, well, that is what it is. But where in cases where that's not necessarily available, people do default to things such as using WMI, using services, or using scheduled tasks. And another thing that helps out with this is the fact that tooling that abuses these built-in Windows features is so prevalent. There's a lot of different open source tools out there that people have either modified or just use off the shelf to sort of achieve these goals. I would recommend for anyone looking into trying to detect these sort of things to actually use all those different open source tools and try to see the telemetry they generate. Make sure that you have something running on your system that can capture that telemetry first, maybe something like Sysmon, and from there grabbing all the logs and figuring out how can you discern a malicious usage of, say, scheduled tasks or services, or just a weird RDP connection. That common for lateral movement. I was originally going to include that, but I decided that might be a little too time. But it is another Windows feature that can effectively be used to run commands on a remote computer. Just it's a little more, I guess, it's a little more convoluted in how that process is done, but COM is another technology. Technically, WMI uses COM too. That Bill? You want to build oh, sorry. Oh, if you want to build an environment where you can sort of test these different techniques and see the telemetry they generate, it's as easy as just setting up a Windows machine, a virtual machine, and a attacker machine. It could be anything. I would choose Kali just because it's convenient, and Kali has all the tools bundled in and installed with it. But since you created the Windows virtual machine, you have the administrative credentials and you can start running all the different attacks I listed off. I would also suggest going into MITRE attack site, looking at the different TTPs they have regarding how actual actors have done lateral movement and different ways they've gone about it. They're just replicating it within your own lab environment, seeing what logs does it generate. If you're more on the offensive minded side of things, maybe taking a look more into how these technologies can be used in ever so slightly different ways to avoid triggering those common detections that defenders have known about. There are a lot of blogs and write-ups about how people have used these different techniques in the past. So that will also probably be very helpful if you don't want to start blind. Other questions? So